Hello students, today we are going to learn chemical properties of phenol. Phenol contains functional group OH as similar to that of aliphatic alcohols, but due to presence of benzene ring, the properties are different. Generally, phenols undergo electrophilic substitution reactions which is due to benzene ring. The first chemical property of phenol is acidic nature of phenol. The following reaction supports the acidic nature of phenol. The first reaction is phenol reacts with active metals to form sodium phenoxide and hydrogen gas is liberated. In addition to this, phenol also reacts with alkali to form phenoxide and water. It also changes blue litmus red. This shows that phenol is acidic in nature. If we compare the acidic nature of phenol with alcohols, we find phenols are stronger acids than alcohols. The acidic nature of phenol is due to resonance as shown below. You can see here that due to resonance, oxygen acquires a partial positive charge which weakens the OH bond and thus facilitates the release of proton, giving phenoxide ion. Phenoxide ion in turn is further stabilized by resonance, which is shown below. If you compare the resonating structures of both, we find that phenoxide ion is more resonance stabilized than phenol. Because in phenoxide ion, if you see the resonating structure, none of the structure you find that oxygen bears a positive charge. But in phenol, we find that three structures, 3, 4 and 5 bears a partial positive charge on oxygen. So phenol always has a tendency to give more stable phenoxide ion by releasing proton, which explains the strong acidic nature of phenol. In case of alcohol, neither alcohol nor alkoxide ion is resonance stabilized and hence acts as weaker acid. Now let us see how the substituents affect the acidic strength of phenol. If any electron withdrawing group is attached with respect to OH, for example nitro group, in that case, we find the phenoxide ion is stabilized more by dispersing the negative charge, which increases the proton release and thereby increases the acidic strength. Whereas if any electron donating group is present, like methyl group with respect to OH, the due to electron donating group, we find it increases the intensity of the negative charge and therefore the proton release becomes difficult and thus the acidic strength decreases. This is first chemical property. Now moving on to the second chemical property of phenol, which is due to reactions of OH group, in which the first example is reaction with neutral ferric chloride. We find here that when neutral ferric chloride is added to phenol, violet or purple color is obtained or observed. So this reaction can be used as a chemical test for phenol. It's a very important reaction, students, because always in board question paper you get questions based on that give a chemical test to distinguish between different pairs. So wherever you find phenol, immediately you can write this chemical test, that is name of the test neutral ferric chloride test, and observation is your violet color. Next example here is esterification reaction. Esterification you have studied I think in class 10th, where carboxylic acid reacts with OH group to form ester. Now in this we find phenol reacts with carboxylic acids, acid chlorides and acid anhydrides to form ester. Examples are shown below. Next example is reaction of phenol with zinc dust where benzene is obtained. Third chemical property, which is the most important property as shown by phenol, that is aromatic electrophilic aromatic substitution reaction. Electrophilic substitution reaction you have studied in class 11, that is reactions of benzene. First example under this is halogenation, where we see bromination. Now in bromination we have two different conditions. One is bromine water, addition of bromine water to phenol, and second is addition of bromine in presence of non-polar solvents like carbon disulfide or carbon tetrachloride. In both cases we find different products are obtained. If bromine water is added to phenol, we get a tri-substituted product, that is white precipitate of 2,4,6 tribromophenol is obtained. Since here we are getting a white precipitate, so this reaction can also be used as a chemical test for phenol. Earlier we have seen that neutral ferric chloride test can be used. Similarly, we can also use this bromine water test for phenol, where you get white PPT as an observation. Second is that if we are adding bromine in presence of carbon disulfide, we see here that we are getting two different products, that is mono substituted product, that is ortho substituted product, and para substituted product. Now this can be explained on the basis of polar solvent. Due to that, in presence of polar solvent, that phenol ionizes to form phenoxide ion. Due to presence of negative charge, the oxygen of phenoxide ion donates electron to the benzene ring to a large extent. As a result, the ring gets highly activated and hence tri-substitution occurs. So that is why we get two different products. Next example under substitution is sulfonation. Again we find when concentrated sulfuric acid is added to phenol at different temperature, we get ortho and para substituted product. In nitration also, with dilute nitric acid we get ortho product and para product, that is mixture is obtained, whereas with concentrated nitric acid we get 2,4,6 trinitrophenol, which is also called picric acid. The picric acid which is prepared by this method is of poor yield. Nowadays picric acid is prepared by converting phenol to disulfonic acid, that is by sulfonation, and further treating this with concentrated nitric acid gives better yield of picric acid. Next reaction is example, that is Friedel-Crafts alkylation reaction, which is a name reaction. Now in this, phenol when treated with CH3Cl, that is RX group in presence of anhydrous aluminum chloride, which acts as a catalyst, we get ortho and para product, where para product is the major product. Next example is Kolbe's reaction, again a very important name reaction. Name reaction always it comes in board question paper. So class 11th you have studied many name reactions. These name reactions also you add to that list. Kolbe's reaction involves interaction of phenol first with sodium, where we get sodium phenoxide, and this sodium phenoxide is then treated with carbon dioxide at 400 Kelvin under a pressure of 4 to 7 atmosphere, followed by acid hydrolysis, which forms orthohydroxybenzoic acid, which is also called salicylic acid. It's a very important compound because it's further used in preparation of aspirin or antiseptic like Celol, etc. The reactions are shown below, that how you can prepare these compounds by using salicylic acid. Next reaction, again very important, that is Reimer-Tiemann reaction, another name reaction. Here phenol is treated with chloroform and aqueous NaOH at 340 Kelvin, followed by acid hydrolysis gives orthohydroxybenzaldehyde, or which is also called salicylaldehyde. In this reaction, in place of chloroform, if carbon tetrachloride is used, we get again salicylic acid. the last reaction of phenol, that is oxidation reaction. Phenol reacts with chromic acid to form benzoquinone. Students, this is all about chemical properties of phenol. I think you have all understood the properties. Thank you, one and all.